So today we're in section 6.5, looking at similarity and measurement, actually measuring side lengths and a couple other things today. But it really comes back to figures being similar. If they are similar, then I can set up their ratios in a proportion to solve what I don't know. But the figures being similar is the key. Basically, if they're not similar, there's no way for me to predict what a side length is going to be. Does that make sense? All right, there has to be some sort of ratio. All right, so we're going to come back to this first slide in just a minute. We're going to start off with these two figures, finding an unknown side length in similar figures. And what we're going to do is we're going to set up a proportion in order to solve for the side length that I don't know. Sorry. In order to solve for the side length that I don't know. Okay, so what side length is it asking me to solve for?
EH.
Side EH. So that's going to be the first thing that I write in my first ratio is the side length that I'm solving for. Now I need to find its corresponding side length to complete that ratio. What is the corresponding side length? AD. Okay? Now, it's important that I know which figure was my first figure. So basically, EH, now I'm going to go over to that figure. This is the one that has to go in my numerator. What side length in the first figure do I know? Did it give me the dimension? What side length? FG. So FG needs to go in the numerator. Now, I've got to make this very clear because if you get this switched up on your homework or on a quiz, you're going to get it wrong. The reason I did side FG is because these two sides are in the same figure. Does that make sense? Remember how I said about matching it up, top and bottom? Well, I've got to match it up. Both in the numerator have to come from the same figure. Does that make sense? Okay, so now what is the corresponding side to FG? BC. So now I have my proportion set up and I can plug in my values. Well, I don't know side EH, so I'm going to substitute in an X for that one. What is the value for side AD?
16 inches.
And what's the value for side FG?
30 inches.
And what is the value for side BC? 12. Okay, and now my proportion is set up and I can solve, and I'm just going to go ahead and tell you, you should probably use cross products, okay? You could use algebra, but equivalent ratios is not practical. I would just do cross products, all right? Go ahead and solve that proportion. That's something we've been doing, so that should just be review. 12x equals 480. Divide both sides by 12. X equals 40 inches. Don't forget to label. Or you could say side EH equals 40 inches because that's technically what you solved for. Either answer would be acceptable. Either one's fine. All right, who got 40 inches? You get 40 inches? Okay, so setting up the proportion is going to be the challenge, all right? I don't doubt that we're to the point now where most of you are solving proportions without error. It's setting up this right here that I have in black, all right? And remember, we just start with the side length that we're solving for, and then we start matching up corresponding sides. So now we're going to look at triangles, and we're going to do the same thing. It says, given triangle STU is similar to triangle DEF, find side DF. So I want you to try to set up your proportion. That's the hardest part. But again, we start off with the side we're solving for, match it up with its corresponding angle, and then remember to go in the same order of the sides on the other, or the figures on the other side. Okay, so that part is important also. Okay, so I'm solving for side DF, so that goes on top. And then what's the corresponding side? Good, Talmadge, very good. SU. Okay, so now I started on the triangle DF, so what side do I know from that triangle? EF. Very good. So EF goes on top on the other side. You see how we did that? All right. Now, what's the corresponding side to EF?
TU.
TU. Now we're set up and ready to substitute our values. Okay, so DF, I don't know. What's SU?
35.
35. What is EF?
36.
And TU? 45. Now we can do our cross products. Are y'all done solving?
Yes.
Okay, so 45x equals, what's that going to be?
1260.
You agree, 1260? Y'all agree with that? Are you sure?
Yeah.
Okay, double check that. All right, and divide both sides by 45.
Yep.
And x equals,
48 millimeters.
nice when it works out evenly. X equals 28 millimeters. Okay, any questions? Any questions? Who got that right? Start to finish, who got that right? If you missed it, do you see where you went wrong? Are you catching on a little bit more? Okay, hopefully we'll have time to practice one more at the end. Okay, so in example 2, we're going to use something called indirect measurement. You can use similar figures to find lengths that are difficult to measure directly. All right, so let's say, one figure you can measure with a tape measure, and you know that some really, really large figure that is difficult to measure with the tape measure is similar, then you can use their ratios to figure out the length of the distance without actually having to measure it. That's why we call it indirect measurement. All right, so we have a cactus example. You like my cute little cactus? Okay. It says, the height of the cactus is unknown, but it casts a shadow of 5 feet. The man is 6 feet tall and casts a shadow of 2 feet. So we can set up a proportion to find the height of the cactus. And there's multiple ways I can do this. I can do height over cactus over height over man, and then shadow over shadow. I could just turn this into a ratio and this into a ratio and make that into my proportion. Okay, as long as you're comparing the same thing top and bottom. So if it's height of cactus over shadow of cactus, it needs to be height of man over shadow of man. Do you see that? Okay, so go ahead and try to set up your proportion. Again, multiple ways that we could do it, but I'll just give you just a minute to go ahead and set it up. Okay, so someone raise your hand and tell me what's the proportion that you used, Avery?
H over 5 equals 6 over 2.
Yeah, I mean, that's pretty much the most simple one. H over 5 equals 6 over 2. Like I said, there's multiple ways to do it, but that's probably the way I would have chosen. So 2H equals 30. Divide by 2. Divide by 2. H equals 15 feet. Pretty simple. Okay, 15 feet. Very good. All right, any questions? Any questions? Anything? All right, so that's indirect measurement. Let's see. We're going to do one more of these. This says the cactus is 5 feet tall and casts a shadow that's 1.5 feet long. How tall is a nearby cactus that casts a shadow 8 feet long? Go ahead and set up your proportion and solve. Okay, so what proportion did you use? Someone raise your hand and tell me. What proportion did you use? Janie?
5 over 1.5.
That's the one I did too. 5 over 1.5 equals H or X over 8. Okay, and again, I did height over shadow on both sides so it matches up. So now I have 1.5x equals 40.
Okay, so I did get it right.
All right, and x equals
26.6 repeating.
26.6. And technically that's 26 feet 8 inches. But you could just say 26.6 repeating. That would be fine. Okay. Who got that right? Who got that right? Okay, so more people than the first one, so that's good. That's good. Are we catching on? Any questions? It's 26.6 repeating feet, or you could have said 26 feet 8 inches, which would be the more accurate answer, but I'm good with either. All right, guys, example 3. Okay, so it says use algebra to solve still for the unknown side length. What do you see here? What is the large shape? What shape is that? The large one. Very good. And then side DE goes through the middle, but DE forms what inside that big triangle? Another smaller triangle. Very good. So here's what I have. I have a bigger triangle and then a smaller triangle inside that bigger triangle. And I'm trying to solve for side BE. Well, here's my challenge. Side BE is a part of the length of my big triangle. You see that? Okay. So when I set up my proportion, I'm going to set up height. So I'm going to set up my big triangle first. The height over the length. And then for my small triangle, I'm going to go height over length of my small triangle. All right. So that's where I'm going with this. Some of this I just have to basically show you by doing it. But the good thing is that most of these problems will be solved the exact same way. So once you kind of catch on to it, the process of it, you'll be able to do multiple problems just like this. So I have side AB, which is the height of the big triangle, over side BC, which is the length of the bigger triangle. Does everybody agree with that? AB over BC, height over length. Y'all agree? Okay, so now I'm going to do the same thing with the smaller triangle. DE over EC. Okay, that's my smaller triangle. DE over EC. All right, but here's my challenge. None of these values I set up, my proportion, but none of these values are the actual value that I'm being asked to solve for. So I need to look more specifically here, side BC. Do you agree that that would be side BE plus side EC? Do you agree? So what I'm going to do is I'm going to break side BC down into its parts. AB over BE plus EC. And now I've got my BE that I'm solving for. So basically, do y'all understand that BE plus EC gives me BC? Do y'all understand that those two together will give me the whole length? All right? So I broke that down. That's probably the most challenging part, and you just have to, just basically learn that I can break down a side length, add the two together, and that's how I can do that. All right, so equals DE over EC. And now I'm ready to start my substitutions. So I can plug in my value for AB. What's my value for AB?
20.
Okay. Yeah, I want green. Okay, so 20 over, I don't know BE, but I know that EC is 36. Okay, and DE,
15.
DE is 15. And EC is 36. Okay, so now I'm still going to do cross products to solve this proportion. The only difference is I'm going to have distributive property. 36 times 20 is 720, I think.
Yeah.
Wait, so you would multiply.
Yes, now you're going to do 15 times x plus 36.
Oh, okay.
Yep, distributive property. So you multiply diagonally still, but now you have distributive property. So go ahead and do this distributive property. Go ahead and do that on your paper. All right, so 720 equals 15x plus, what is 15 times 36?
15 times 36 is
Okay, now I subtract 540.
equals 180 divided by 15.
Subtract 540. And I get 180 equals 15x. Divide by 15.
X equals 12 inches.
Oh, I love it when it works out evenly. X equals 12 inches.
So if online with grades or something, we put x equals 12 inches instead of BE equals 12?
Well, I would say either one. More specifically, and the most accurate answer is to say side BE equals 12 inches. But I will be perfectly happy if you make it through all those steps and you get to the right answer. There's no way I'm taking off if you don't say side BE, okay? So there's a lot involved in this. All right, hopefully, it makes a little bit of sense, but we're going to practice more. So that's definitely something we're going to be reviewing multiple times between now and quiz day. All right, if you understand that, that's everything you need to know for section 6.5.